High above the runway, before a single wheel leaves the ground, time seems to slow. 8 engines begin to breathe, metal warms under rising pressure, and a machine designed more than half a century ago prepares to fly once again. Few aircraft in history inspire the same sense of scale and continuity as the B-52 Stratofortress. Built for a world shaped by Cold War tension, it continues to operate in an age of satellites, automation, and digital warfare. How does an aircraft conceived in the early 1950s remain relevant today? The answer lies not in speed or stealth, but in discipline, engineering endurance, and a cockpit that bridges generations of aviation history. If you enjoy calm, in-depth stories about aviation history and the machines that shaped it, take a moment to like this video and subscribe. Many more carefully researched stories from the past are still ahead. When the B-52 first took shape in the early years of the Cold War, its mission was clear: fly farther than any bomber before it and carry a payload large enough to deter global conflict. Designers focused on range, reliability, and adaptability rather than speed. The result was an aircraft with a wingspan exceeding 180 feet and a fuselage stretched to nearly 160 feet, optimized for long hours in the air rather than brief, aggressive sorties. Unlike many aircraft that were retired as technology advanced, the B-52 evolved. Over decades, it received upgrades to avionics, navigation systems, communications, and mission equipment. These changes allowed it to operate in environments far removed from those originally envisioned. Yet the core airframe remained largely unchanged. Its structure proved strong, flexible, and capable of handling repeated modernization cycles. This balance between original design and gradual improvement explains why the aircraft did not become obsolete, but instead grew more capable with time. One of the most distinctive features of the B-52 is its propulsion system. 8 Pratt & Whitney TF-33 engines are mounted in paired nacelles beneath the wings. These engines are known not for efficiency by modern standards, but for durability and predictability. They require careful preparation, including long warm-up periods to reach proper operating temperatures. In rare situations, speed matters more than routine. For this reason, the B-52 can use a cartridge start system, where pressurized gas from special cartridges spins the engines to life almost instantly. Thick clouds of smoke burst from the exhaust during this process, a dramatic reminder of older aviation practices. When executed correctly, this method can reduce ground time significantly, though it demands strict discipline and precise handling. Despite its size, the B-52 shows very little visible rotation during takeoff. The aircraft's weight and landing gear geometry mean that the front and rear wheels leave the runway almost together. This same geometry makes landings demanding, particularly in crosswinds, often requiring long runways and the use of drag chutes to slow the aircraft safely. Keeping an aircraft of this scale operational requires constant attention. The B-52 has earned a reputation for being maintenance-intensive, particularly its engines. Each power plant follows a strict service schedule based on age, hours flown, and operating conditions. In many cases, entire engines are removed and replaced with refurbished units, while the originals are sent to specialized facilities for overhaul. Maintenance extends far beyond engines. Crews regularly inspect the airframe for corrosion, fatigue, and wear. Many repairs are still performed by hand, including shaping replacement panels and reinforcing structural elements. Techniques such as cold bonding and precision fitting reflect a maintenance philosophy rooted in craftsmanship rather than automation. This approach ensures that even after decades of service, the aircraft remains structurally sound and safe to operate. Stepping into a B-52 cockpit feels like entering a different era of aviation. The flight deck is spacious compared to modern fighters, yet densely packed with analog instruments. Rows of circular gauges display engine performance, fuel flow, hydraulic pressure, and electrical output. While digital systems have been added over time, many original instruments remain in service due to their reliability. The pilot and co-pilot sit side by side, managing 8 throttles and a wide array of mechanical controls. Unlike fly-by-wire aircraft, the B-52 relies on physical linkages, cables, and powered actuators. Every movement of the control column is translated directly into motion, requiring strength, coordination, and experience. Behind the pilots, additional crew members manage electronic warfare, radar navigation, and mission planning. Even with modern upgrades, many tasks demand manual input, reinforcing the importance of teamwork and procedural discipline. The B-52 typically flies with a crew of 5 or 6, depending on mission requirements. Each role is clearly defined, and coordination is essential. Systems that are automated on newer aircraft often require deliberate human action here. This reliance on skilled operators has proven effective across decades and theaters of operation. From Southeast Asia to the Middle East, the aircraft systems have demonstrated consistent performance under varied conditions. Its continued service is not a result of nostalgia, but of practical value. The B-52 remains a platform capable of long-range missions, flexible payload configurations, and sustained presence. It stands as evidence that thoughtful engineering, combined with disciplined crews, can extend relevance far beyond original expectations. What truly sets the B-52 apart from other military aircraft is not a single system or feature, but its relationship with time. While many platforms are designed around rapid technological cycles, the Stratofortress was built with margins: structural, mechanical, and operational. These margins allowed it to absorb decades of upgrades without losing its identity or reliability. Engineers did not attempt to make it the fastest or the most advanced aircraft of its era. Instead, they focused on predictability, serviceability, and endurance. The aircraft's large wings provide stability rather than agility, smoothing turbulence during long-duration flights. Its systems are intentionally accessible, allowing crews and maintenance teams to diagnose issues without relying entirely on software. This philosophy has proven invaluable as electronics age and supply chains change. In many cases, analog components can be repaired, recalibrated, or replaced more easily than complex digital equivalents. Equally important is the culture built around the aircraft. Generations of pilots, navigators, engineers, and technicians have passed down procedures, habits, and unwritten knowledge. Checklists are followed meticulously, not out of routine, but because experience has shown that consistency keeps such a large and complex machine safe. Every pre-flight inspection, every engine start, and every landing reflects this accumulated discipline. In an era increasingly defined by automation, the B-52 represents a different approach to aviation. It relies on human judgment, mechanical feedback, and teamwork. This balance between man and machine has allowed it to remain operational long after many contemporaries were retired. Rather than being frozen in the past, the Stratofortress continues to adapt carefully, proving that longevity in aviation is not only about innovation, but about designing systems that respect time itself. If you enjoyed this story, like the video, subscribe, and turn on notifications. That way, you won't miss future stories exploring remarkable machines and the people who kept them flying through history.